Hello again, everyone. I'm finally going to get the courage up to try and do this MFC lecture. Hence, new outfit, in case you didn't notice. How dare you not notice? Um, we're going to go over MFC again, and I want to just bring up where we're going to start. Lots of slides. We're going to blaze through this, not because it's so critical. I'm not going to take my sweet time on this, just other than to find where my thing starts. It's halfway up here. The reason we're going to blaze through this is not because it's because it's not going to be on the exam, and in general, my general consensus that I've been getting from students is it's not on the exam, and you have to do it for one homework, just enough to be dangerous. Just get through this. Okay, so we're going to look at MFC dialogues. I'll hopefully do a live coding demo. I also have two other coding demos. They're all under L14 in the in-class code section. You are not supposed to understand what all that code means. Just to be very clear, I don't understand what most of this code means, and I wrote it, or at least generated it. The reason is that MFC generates a lot of code. Part of what I'm trying to demonstrate here, in case you're not quite picking up on some of these little subtle things, is you're not going to understand all the code in a code base. That is sort of a fact of life. I'm not going to sing that song in case you know the show. It's just sort of what you get used to, and sort of getting exposure to seeing a whole bunch of code and trying to sort through it and figure out where you're supposed to be looking, where you're supposed to be editing things. You're not going to understand all the various parts. Just like when you're fixing a car, you do not discover every last little bit of the car. You're looking at the one part of the car you're trying to fix, and that's about it. Now, you're supposed to probably know more about cars, but you're not supposed to. Every time a car goes into the mechanic doesn't know every last little bit of every last little, oh, there's a bit of rust on that nut over there, right? No one knows that. And so we're in a similar situation here. In case you were wondering, why I have no idea what happened with the lights there. In case you're wondering, why is he giving us so much code? That's the reason, one of the reasons. You have to get used to that, and that takes exposure. Getting used to just accepting you cannot understand all the code base. Okay, let's actually get going on what the real point of this is. So, when we're talking about Microsoft Foundation class, they're designed in C++, just for review. They're a Windows GUI. They give you the look and feel of a Windows application. That's the reason they were invented. Of course, that's very limiting, but at the time when these originally came out, pretty much Apple products were down in the dumps, right? No one had a Mac. And so it sort of made sense to a certain extent. They were sort of in control of everything, and everything looked like a Windows application, and great. It was a big hit. Not that useful anymore, but so that's why we're not dealing with the nitty-gritty details of all of this stuff. But it's useful as a layout tool. So the idea here is they're going to make all the boilerplate code for you. You're going to use a whole bunch of libraries that are shown to work. You hide the Windows main program. You're not worried about handling all the event handling and stuff like that. All you do is hook up events. Hey, we're learning about events. Here's another example. You hook up events for getting callbacks for, when someone clicks the mouse, do this. That's all we're doing. Lay some stuff visually, hook up a callback. So it is not meant to be a deep dive at all. All the low-level handling is done for you. It's correct. It's optimized. It's robust. I'm assuming it's correct. That's questionable always when it comes to programmers. But it's a WYSIWYG approach. It's a what you see is what you get. I'm going to move stuff around, and when I put it there, that's where it's going to go. You don't have to explain pixel by pixel how to draw some things. And when a user clicks a button, the button does everything you would expect for an update, and it calls prearranged functions, and a lot of the boilerplate common stuff is handled for you. It's actually one part of a much, much larger ecosystem. We're just looking at the graphical part of things. But it does OLE, it does internet services, it does structures, it does exception handling, it does as application architecture, databases, it can hook up a database. You can do all sorts of things with MFC. We're not doing all those things, but just in case you wanted to see where things are. And this is what we're doing. We're doing the dialog right down here. Let me get my pen right here. We're doing this dialog, but other than that, we're leaving off the other stuff. MFC applications are generated by driving from other classes. So you will actually see, at least in the slides, you're going to see why we need to know inheritance. We're going to take the MFC dialogs and the MFC applications, and we're just extending them. So the basic functionality allows base class to be empty, and then you just add layers on top of that. Programmers add functionality on top of this base class, and you're good to go. You don't have to know all the gory details. The onDraw is called when the paint message comes through. You don't worry about that. Somebody else handles it. That's boilerplate code. That's code that's automatically generated code. The app wizard automatically overrides these methods that you need to deal with, and the programmer's code, if you wanted to add something to paint, you could add something to paint. So we're going to walk through, I'm going to do a live demo eventually of this, but I want to go over the slides first. So what we're going to do, and the slides will also give another example of how we go through this. So we will make an MFC application. The interface is going to look different for Visual Studio 2019, but close enough. I make an MFC application. It'll be dialog based. I will use MFCs in a shared DLL. That's fine. It's English. And it looks like this. When I generate it, I will get a bunch of source files. I'll get a bunch of resource files, including RC files. The RC files are essentially my dialogues. You can even turn off the about dialog, which is nice to do. And we get a bunch of header files. Okay, the code looks like this. Great. We have dialog boxes, we have strings, we have bitmaps, we have icons. We have all these resources all bundled together. That's what these RC files have. We're going to be dealing with the dialog boxes and modifying those. But when you make a new string, a string resource goes in there, as in they have this sort of permanently hard-coded string value that they keep somewhere else that gets put into your dialog. Same with a bitmap. Yeah, I add a bitmap to the MFC dialog box. The image will be included in this RC file. So let's have a quick look. This is what the dialog might look like. Great. What I'm going to end up doing is I'm going to place down. See how see how I have a toolbox over on the left-hand side here. I'm going to be able to click a button, drag it down. Click an edit control, drag it down. Drag it in there, move things around, and then I will change the properties for that dialog by setting flags over here. So drag stuff in here, then set whatever's highlighted, like button 1 in this case. I can set how the default behavior is, what the name of the ID for the button is. It's not ID, it's IDC button 1 right now. I could change it to whatever I want it to be. So we add UI components, we have a properties window, and we change things. We can also even override what happens in terms of an event. So this is what this lightning bolt is. It's not Zeus coming down. It's for if I want to kill the focus, when the focus is killed from the button, what do? If I double click the button, what happens? If there should be one for just on button click. Okay, the button clicked. If the button is clicked, like you would expect, I want an event. And when that event happens, what you're going to do, it's automatically going to generate a function for you. It's automatically hooked up so when that button is clicked, that function gets called. And I'll fill in that function call to do stuff. Okay. After that, I'm going to add a variable if I need a variable. So let's say I have text in this dialog here. So I type in some text in this dialog here. I then, when the focus for that dialog is removed, I then save whatever the text was to some outside variable. That outside variable grabs the text and will then send that message to when button 1 is clicked. I'll have some global variable sitting around with the same text is what's on this dialog. I press button 1 and I get a message saying what's in the text field. So I'm adding a variable. And so we have a bunch of different kinds of variables, but with our MFC dialog, what we have is the C Windows app and the C Dialog. So it's a dialog box. The Windows app is the general application. It initializes everything, it sets everything up. It's the app has we have global variables for this, and each dialog, it's its own CPP file and .h file, and the about box is generated automatically unless you turn it off, and we have one main one that we're going to have. So we have an application and we have a dialog, or maybe two dialogs if we auto generate the about box, but that's it. We have no main function. The app starts, I initialize an instance of it. When I initialize that instance of the application, I will generate the dialogues. I will then call do modal to show the form, and then it's closed. And quite frankly, you don't need to touch that. Right? The app is pretty much untouched by you. The dialog is where we're doing all our stuff. So what we're going to be doing, we're going to create a form. We're going to add some objects, dragging it manually. This is what we're going to show soon. We're going to set some properties. We're going to probably get upset when it doesn't work. We're going to add event handlers in the form of a designer. So when I click something, do this. We're going to add some variables to the controls so that I can pass information around. And if I need to, we can add extra functionality or change how things work. So I'm not going to do this exact demo, but there is a demo of this currently in the, I think it's called temp converter. There's a demo of this currently in the shared code repository. So I would make, this is not lecture 7, but still good enough. A DegreeConverter, it's an MFC application. It's dialog based. We're going to go through all those. We would, we were going to remove the various options. And for advanced features, the setup would be for user interface features, we remove all the options. Advanced features, we remove all the options, and we rename the generated class instead of this CMyL7 degree, just call it DegreeConverter app, DegreeConverter dialog, if you want to do that. Then what we would end up doing is so right now we'd have this to-do place dialog controls here. We're going to remove that. We're going to add 2 edit controls. We're going to add 2 static text fields. We're going to add 1 additional button. Other than OK cancel, it's just going to be button 1. Let's say convert. And then for each of these things, we're going to change the field. So I can go select button 1. I could go to the properties for button 1, and I can change what the caption is for button 1. I can change how it responds. I can change what I could click one of these text fields here and change what the caption is. And if we run the code, it would end up looking like this. And if we run the code and it looks like this, nothing works. Right? You can do all you want. Nothing's being converted. It's not magic. It's just the visual interface. Once I have this, and you should always test your code first, so you set everything up, test that it works, and then add the logic. So when I put some field into Fahrenheit and then press convert, I expect the field to go into Celsius, the value. So I put in 100, nothing happens, but OK and cancel do work, so the window at least closes. So we need some variables to access and modify the content, and I like pointing out my screw-ups when they happen. So in fall 2019, I got stuck in there somehow, and I was looking like I added these variables, went to look at how this thing actually works, and I could not figure out why messages were not being passed around correctly. Turns out we have 2 different types of variables. The lab covers one type of variable. This lecture series covers another type of variable. You can either have a control variable, or you can have just a normal variable like a Boolean or a string. A control variable is supposed to be what the content, it will modify the content of a control, like a edit dialog box. Just a string, well, or a boolean or an integer, you can just keep those around as well as global variables. And if you modify it in one of your fields, you just modify that variable, and then you need to do some other work. But there are two different approaches, one for control variables, one for normal variables. Okay. So what we're going to do is we're going to add a variable. We'll right click on a particular object, like the top edit box, add a variable, and either you make a edit variable or another kind of variable. So in our case, what we would end up doing for this example is I'd have an edit variable for the top box, edit edit for member variable, edit F for Fahrenheit, or edit C for Celsius, and that would be my variable, my control variable. And then when we're in here, we're going to, so when we get this on button clicked, on button clicked button 1 message. So I say I'm going to add a callback. I get this. It's automatically generated for me. Now in here, I'm going to handle what happens when somebody clicks that button. So somebody clicks that button, I'm going to get the text from this control variable. I'm going to get the text, the window text, and I'm going to put it into a string. That's what this line here is saying. So as long as I have a control variable, I get the text, get the string, and I do the conversion. So this is only going to go from Fahrenheit to Celsius. It's not going to go from Celsius to Fahrenheit. So I will get the control. I will get the text for that control. I will convert the text to a double. So I'm going to convert this underscore W would be it's got to be text though, right? To F. So I'm converting a string to a floating point number though for this conversion. It's going to convert it to a double. So W2F converts a string to a double right here. Then I'm going to just do some math, the normal math way of doing things, and then I'm going to change my string. I'm going to format it so I put in that floating point number, and I'm going to convert it back. So I'm going to go from that double, whatever that new version of the double is, back to a string, put it in here. And then I'm just going to edit this Celsius field, setting the text to being that string. Okay, so I get the string from the Fahrenheit, turn it to a number, convert it, put it back into a string, put it into the Celsius field. So when I type this, and this code is shared with you, when I type in this and I press convert, I will automatically stuff things over here. This is what you'd expect. And we've created a full application, and I'll actually hopefully give you a nice example of this. But let's break down these little parts. So what do? We have the Solutions Explorer. We only dealt with these two things. There's a DegreeConverter.h, DegreeConverterDialog.h, and the application you don't need to touch. That's the application window. It's all covered for you. It's generated, it's new, but you don't have to touch it. The dialog you do need to modify, but you're not really directly modifying. You can look around. Go ahead. Look in DegreeConverterDialog.h. Good times. And then afterwards, what we're going to do is we have a Resource Explorer. We're going to look at the dialogues. So in the Resource Explorer, we're going to look at dialog, this IDD dialog, DegreeConverter dialog. And it allows us to visually modify things. So, by the way, in case you're wondering, the degree conversion app comes from CWin app. It's a class. We're extending it. Degree Converter Dialog, it derives from C Dialog EX, which we extensible or executable. Anyways, it's the dialog. Oh, doesn't matter. This is, I'm extending this class. So these are two classes, we're extending them. And since we're driving things, we get all the power from the parents, and we just need to add a little bit of code. That's why we looked at inheritance. So we have a Windows object, we have an application object, we initialize them. The application object handles all the low-level processing. We don't need to touch it. The Windows objects handle see dialogues and see frame windows. They encapsulate functionality for creating a particular window, creating a particular dialog, and you can play around with it. You can add controls. I forgot to remove these little arrows that I was going to put in there earlier. So the C Windows application, each application only contains one object derived from C Windows application. There's only one of them. You can have multiple dialogues. And it has AFX Windows initialization. We have registering of classes. We have initializing instance. We have running. We have pumping messages. All of it given to you. That's why we have it the way it looks. But you don't have to do any of this. But all of this, taking in messages, pumping them out to other places, doing all the callbacks, all that plumbing is done for you with MFC. We'll be doing that plumbing ourselves for the next assignment. The minimal program, though, is I have an application class, I have a Windows class, and all of these things will include AFX win.h to bring these classes in. And we have a bunch of resource files. Okay. Here's the big thing I wanted to point out. So this is the DegreeConverter app. We have an initialized instance. We don't need to do anything. Great. Derived from WinApp. New class created. Fine. And instance is a virtual function called for the application begins. Notice we have this virtual, right? The parent class, we're doing what the parent class is unless we initialize, make our own version of it. We're going to be doing that, but we're still going to call the parent's version of it. So here's a DegreeConverter app. Here's initialized instance. I am going to call the parents. This is how I call the parents version of an init instance. I put the name of the parent and 2 colons. Do the parents version of an init instance, which we've hopefully have already seen before. And then I'm going to deal with the dialog, DegreeDialog, and I'm going to do something with the DegreeDialog. Pretty much, once you created this class and implement init instance, you don't need to touch it again. And in fact, we don't need to touch it at all. It's done for you. All this stuff is hidden away in CWin app. We have no main loop, no loops of any kind. It's all being done by other people's code. That's the point. Event handling is completely automatic and invisible in MFC. The DegreeConverter dialog, however, is a different beast. We have something called a Do Data Exchange, or DDX, that we'll talk about in a second. We initialize our dialog, we have on-paint methods, and we have every single time there's a button click, we have this. Now, we're not dealing with the on-paint unless you really want to get cutesy and draw things during the paint method, but I got rid of all of that stuff. We're going to look at the on-click messages, but also notice here are public global edit variables, allowing me to change Fahrenheit to Celsius. Some things that you should never do in your own code is what they had to do for MFC, which is why some people don't like MFC. So we're deriving from C dialog executable. I'm assuming EX for executable. I don't remember anymore. The dialog button callback function. So when I make the dialog button and I push the button, this is the function that gets called. And we have a bunch of control variables. And for some reason, AFX message needs to be in front of what type of variable is being returned. You don't have to worry about that. It'll be generated for you, but in case you see that thing, it's necessary. And here's my edit variables. So here is my on button click, a callback. Once again. Okay. So I'm getting the text from the edit field. I am putting it back afterwards. I have this callback up there at the top right here. I have but the question is, how am I finding the right thing? how am I finding, if I edit this control variable, how does it get put back on the edit field, right? I have this text edit field that magically gets converted by me just changing some variable. How does that work? How the hell do we know that we're going to get this callback? And that's where the dialog data exchange comes in, the DDX. It allows us to convert one thing to another, like to pump messages to and from the controls to variables. So the dialog data exchange, it goes from a control to the using a bunch of macros. It goes from the controls themselves to a variable. So the idea here is I have these variables that I can deal with, and the DDX allows me to go send from the cedit variable to one of our controls. So do data exchange is the name of the function call. The dialog data exchange is, or DDX, is the process. And so the DDX macros transfer data from between the dialog's controls and the members and back and forth, essentially. So I may have something like, let me see here. Here's me calling do data exchange. I have DDX control. I'm converting from this thing and putting it over into the controller that is identified with this ID. These are all IDs. Here are constants. You cannot change them afterwards. IDX edit 1 is a control. So I find the control and I set the value to being whatever this thing is. Or if this thing is if this thing is has been changed, like the control has been changed, then I change the edit control. The DDX exchange says which one's new, change the other one. It links between the two. Okay, and the PDX is an argument to the data C data exchange object, but that's neither here nor there. We actually have two ways of doing data exchange. This is for the assignment, the more important slide of the bunch, and the one I'm going to screw up and forget about. So the two different approaches. So with a control variable, like cedit, I have a control variable. I make one of these control variables. It's stored in my header file. In the DDX, or the do data exchange, in the do data exchange function call, I have this DDX control, and I'm converting from this to this or this to this. Okay, it's just exchanging between the two. When I get the on clicked button function call, I set the window text to something, or I get the window text and set this, or I get the window text and store it in a variable, a string. It is sort of a more direct way of doing it. I just get the text from this control variable, cedit. Okay, that's fine. What if I don't want to use a control variable? Here's the other approach. If I just keep around a global string, right, or a global integer, what I would need to do in the so this is in the header file, just like I had before. This is when I do the do data exchange, I have to do DDX text. So for text, I would have to do DDX num, do DDX int. I'd have to look it up each time. Or I'm going from this edit dialog into this particular string. It's a different function call. Instead of DDX controls, DDX text or DDX num, something like that, depending on the kind of data I'm dealing with. So it looks very, very similar. It's not exactly the same. And when I get to the on clicked button callback, though, what I do is I update the data. I call update data true. I change my variable. So I change what medit f2 is. It should be f2. Instead of c2, it should be f2. It has to be consistent. Okay, I change medit. Let's just put that in there. I'll fix it next time I'm teaching next time I teach this f2. All right, and let's put the 2 in there as well. I didn't see that while I was going over the slides. So I'm going to change this C string, and then I say update false. So I turn on updating, and then I turn off updating after I've updated the variable. That way I have a little window of time where I say, yeah, I'm changing the variable on purpose. You got to update things for me. That's what that thing is saying. Turn on updating, then turn off updating. So now I get this do data exchange call afterwards to change what the fields look like. Two different approaches. You got to just choose which way you're going. I'd like to point out the remaining slides after this are hidden. They're hidden because, well, actually I have a bunch of reasons. You could spend days looking at this stuff, and I don't want to. They're not on the exam. I don't necessarily know this. The tutorials teach you step by step what to do for closer to what you need for the assignment. As in, the homework is as close. It's perhaps the most useful. Not homework. The tutorials or the lab exercise is step by step how to do an MFC. Almost everyone seems to have gotten it when I've done it in the labs in the past. And if you think you're going to do MFC without that, you might have a hard time, right? Just do the lab, and then you're ready to go. Just modify and just make a brand new MFC application, a dialog that's going to do almost the same thing or similar things, and you should be fine. So you have step-by-step instructions to do the first version of it. You crumple it up, throw it away, and try your own afterwards. So that's what we're doing for the assignment, but definitely try the lab version first. It's very step-by-step. Okay. And quite frankly, you'll probably stop listening if I keep on rambling on. I'm bored with myself right now. Okay, so the rest of the slides are left. I have a couple more slides just to go over sort of key things that I left out, we haven't covered yet. But the rest of the slides are just in the PowerPoint presentation if you want to have a look. But we're not going over them, with the exception of the following two. So for debugging, you would normally have a cout statement. That's not the case anymore. That's a problem. Okay, what do we do? Well, it turns out AFX dump outputs things to the window. So AFX dump test, and you will dump out the word test. Very useful for debugging your application. So here we go. I have AFX test somewhere in here, and when I press convert the button, I had AFX test in there, and it just popped out the word test. Great. There we go. Also, if I want a dialog box, I can do a message box, _T, X wins, or whatever message I want to have in there. I can have the title for this whole thing. It's game over. And so that's the second parameter. And then I have what the icon is and what the button is in there. So if I want a quick message that does as a pop-up, just copy this, change the text, we're good to go. Okay. I'm going to do the video in a second. Maybe I might break it down into two different videos just in case I screw up the first time. We've looked at all of these different parts, but we're very, very briefly. We looked at message boxes, just there. We AFX dump, how to do output. We looked at messages very briefly. We looked at variables, how to set them up. We looked at the C Dialog EX. And we barely looked at C Windows application because we don't need to. It's all pre-made for us. So next video, I'm going to actually do it as a separate video. Next video, I'm going to do the live demo for what we are talking about here. Okay. See you soon. And we'll stop it here.